Welcome back, everyone, to Pontos Fathom Press. This is our Pontos Fathom Podcast, episode number 73, and I thought I would jump in on the recent Terrance Howard appearance on Joe Rogan, but kind of more from the point of view of kind of like a philosophy of science and maybe history of science and even an epistemological take on it. It seems to be that there's this weird polarization between dumb people who don't know better and smart people who should know better, and memesters and just kind of like snark culture. And I just kind of my take is a bit about hey, let's look at things from an this is from the point of view of somebody who's an academic outsider who's real interested in stuff. I saw some good podcasts on the topic. I watched Eric Weinstein talking about it. I watched the Theory of Everything podcast. Everyone had some takes on it, but I found that there was always a little bit of snark from people saying, and listen, it's all over the place. Terrance's podcast is all over the place for sure. And I thought maybe we could bring it down to instead of it's being so hyperbolic, maybe we could just ground it in an alternate way of looking at things, maybe ground it in a sort of thought experiment kind of context, right? So really the concept comes out of it. He talked about a lot of things from, he talked about one times one equals 2 as opposed to 1 times 1 equals 1 as we traditionally know it. He talked about the square root of 2. We talked about a new periodic table. So all kinds of things. It got into the esoteric, so I thought it was right in our space. He even talked about gravity not existing, and he kind of framed all of it as a great conspiracy, and hopefully we'll try to look at it in a slightly different way. Although I will kind of pull in some personal ideas I have in it too. But I wanted to start out first with some quotes here. I had this one quote. I always remembered it was from an episode of Terminator, the Sarah Connor Chronicles, and they had Cameron, the Terminator robot. She's quoting a Go proverb, and the proverb was, "Strange things happen at the 1-2 point." It's a Go proverb. It means the usual rules do not apply, and I thought that this was really interesting. So, and I'll go into it a little bit. And my second quote here is from George Orwell's 1984. In the end, the party would announce that 2 + 2 equals 5, and you would have to believe it. It was inevitable that they should make that claim sooner or later. The logic of their position demanded it. Not merely the validity of experience, but the very existence of external reality was tacitly denied by their philosophy. Wow. And I almost want to say this is the inverse of Terrance Howard saying 1 times 1 equals 2. We'll kind of go into Terrance Howard's math. What's interesting in the Orwell quote is earlier in 1984, Wilson says, freedom means the freedom to say 2 + 2 equals 4, right? And he was talking about a world in which there was a rationality that existed, and then the politics of the irrationality. You're forced to make the observation and swear by the lie, okay? Now, I don't think that the Terrance Howard situation is at this extreme yet, but the way it's divided, the internet, and the way I see people talking about it, I think I just wanted to call this out, that there was a cautionary thing here about this, right? Let's look at things as things that we can explore, because obviously he's an intelligent guy, and if Terrance Howard comes across this podcast, I would love to, work with you on some of this stuff. I think it's super interesting. And if you're a detractor of it and you think it's hogwash, hopefully you'll stick around a little while, and I want to apply some ways of thinking. We've done a podcast recently. We did a podcast on quaternions and the idea of looking at higher order mathematics. We talked about Giordano Bruno's shadow of ideas and E8 supersymmetry. And I think that some of the intuitions around this, and I want to talk about projection space. So the idea here is a sphere when projected onto a plane is a circle, And you kind of, if you just think of things as circles, you don't get to have an intuition about the sphere, right? But once you know the sphere is there, once you observe that there is a sphere in a higher order dimension, and we talked a lot about this in that podcast, but I want to relate the epistemological approach to Howard's talk, and not so much align it in a conspiratorial way, but more like an observational alternate way. And I'll use Euclidean geometry versus non-Euclidean geometry to talk about that, but hopefully that'll be interesting. And then I'll also jump into some other concepts. What's interesting about the Sarah Connor quote in Go, says strange things happen at the 1-2 point. So the 1-2 point is kind of like, Go, you capture territories by placing white and black tiles. And the usual heuristic rule of capturing and surrounding tiles kind of breaks down in the corners, right? So at the corner, it's almost like the rules are flipped on their edge. And I think that this is what, maybe what all this comes down to is just Terrance Howard's noticing of some interesting things about how multiplication inverses down at that part of the number line. So usually we think of multiplication as getting bigger and division as getting smaller, but when we multiply and divide fractions, those operators are flipped. So also talk about an alternate system of to look at that. One thing that we'll jump into, let's just jump right into the controversy. So the controversy really stems on, these are some screenshots from Howard's, Terrance Howard's discussion of this. And if you guys haven't seen it, Terrance Howard, the actor, he's been working on a number of patents over the years. He was recently appeared on Joe Rogan talking about some really wild stuff. And a lot of it's esoteric, and it's kind of around the stuff that we've talked about. But he also talks about scientific realizations that he's had. And it's thrown the communities into... I've seen everything from people just kind of giving a kind of an ad hominem attack take that he's crazy. There's that out there. Then there's that's the people who don't know better behaving badly, right? And then there's the people who are the scientists and the scientific community kind of just saying he's an idiot because everyone knows 1 times 1 is 2, right? I mean, everyone knows 1 times 1 is 1. And for him to say that 1 times 1 is 2 is just insane, or for him to say that the square root of 2 is 1 is insane. But I want to present it a little bit differently. So the first controversy that comes out of it is Terrance Howard talks about the square root of 2. Now we know that the square root of 4, for example, if we look at the square root of 4, right, the square root of 4, we know this equals 2 times 2, right? But in traditional standard math, the square root of 2 is like 1.14, something like that, some small number. It's a fractional kind of number. If you multiply that out, it's a long repeating number, and you get that squared becomes 2. But Howard kind of says something that is the controversial thing of this is that he talks about that multiplication should be standard and that it should be growing, And I think what he fails to kind of communicate is, I think it's probably something, we'll talk a little bit about complex numbers and about the origin point can be flexible in content in the complex number plane. But yeah, so the basic premise of his concept is that 1 times 1 does not equal 1, but it equals 2. Right? So the concept that's strange here is he says that multiplication should be growing. So I think that where the paradox happens, and I really want to just show the number line. Do I have a picture of a number line in here? I printed out some material. So here's Terrance Howard's kind of thing that broke the internet, right? So he's kind of come out and said, we believe in standard math, 1 times 1 equals 1. And he believes that 1 times 1 could equal 2. And he's kind of portraying this as a kind of conspiracy. But I wanted to introduce it as something that I'm going to call the Terry. And I'm going to make a new symbol here, right here live on the show. This is the Terry. And the Terry system, just like the complex number system, so we have complex numbers. right? The Terry system is when the square root of 2 equals 1. That's what we're going to call the Terry system, okay? Now, it's not the first time we've done something like this in math, right? For example, the paradox of the square root of -1 actually was the idea that you cannot multiply two negatives. You cannot multiply two numbers to get a negative number, right? Because if you have the same number, so if you have -1 times -1, the negatives will cancel out, and if you have positives, there's no negative. So you can't have a square that ends up being negative. So the construct was I got defined as the square root of -1. And what it's interesting about this is it's actually the properties that get revealed by the complex numbers, right? So the complex numbers, in having a real part, A, and then an imaginary part, B of I, you could now have a compound number, like 3 plus 2i here. And this complex number can actually be graphed out into the plane. So you could have the real part and then the imaginary part. And you could take, if you have 3, you go up 1, 2, 3 on the real part. And then 2i, you go 1, 2. And that graphs out a vector that goes out this way. So complex numbers were really a cool, interesting thing that was developed by exploring something that was called imaginary. All right? And this Euler equation is another example, right, of e to the pi 1 over 2, or, there's also e to the -1, something like pi, like this, and it equals 0. So, right, so the idea that 0, so Terrance Howard also saying that 0 doesn't exist, but I think what he's observing is that strange things happen at the 1, 2 point, right? So his concept really is math doesn't behave the way intuition would make me think math would behave. And so he's sort of struggling with kind of coming up with some insights from this. And I thought I came up with one kind of small insight that would help maybe the scientific skeptic here. So the way I wanted to present this was as follows. Let's imagine a triangle, right? So here's a triangle. Let me zoom this in a bit. So let's imagine this triangle. And, we're going to get the square root of 2 is going to be this, right? That's the hypotenuse of this triangle. But Terrance is telling us that 1 times 1 would equal 1 times 1 equals 2. So I said, how could we get this instead of 1.4 x that it would be, right? So the square root of 2 is the square root of 2 is 1.414213, and it keeps going, right? So instead of this hypotenuse being 1.41213, let's imagine that it's 2, and then we can show this version here. So now, let's imagine that there's a curved line so you imagine there's 2, 1, 1, and then although we see this line as the hypotenuse, and in the standard measure that would be 1.414, let's imagine that this line actually curves so that its length is 2, right? But it's actually breaking the plane. So this is what Terrance Howard is sort of talking about a bit. He's saying that when you flatten mathematics to a plane, right? When you flatten math to the plane, we're sort of forced into using, let's call them imaginary numbers, or let's call them, they're real numbers, but they're irrational numbers, right? Something like this, right? So it's forcing us to using even like the ratio, of the think of pi as a ratio, right? Now you could come up with another crazy thing. Let's say, what if pi equals 1, right? And we're going to measure the ratio by just a different units, okay? So what I want to introduce this as is perhaps this is just the way Terrance Howard looked at geometry and multiplication operations in a interesting way that gave him some insights. Okay, it doesn't mean we have to throw out all of science. It doesn't mean that, there's a vast conspiracy. It just means perhaps we could use this as a tool. And that's why I'm kind of presenting it as, if we present it as a Terry, right, this Terry concept. This is an alternate math system, just like we have a complex number system, right? There's a complex number system. And in the complex numbers, we can do equations. Well, maybe in this system, we could do experiments and see what we glean from that, right? So the idea here is in standard math, we have 1 times 1 equals 1. In the Terrance Howard math, 1 times 1 equals 2. But this is a special case. And that's what this Terry is going to mean. Now, what is the implications of it? I'm not a mathematician, but I would feel like there would be some overlap with, you could describe things with standard mathematics in a similar way, but then some things we would learn new properties. So let's take, for example, a similar concept that happened with non-Euclidean geometry, right? So let's take a look at this non-Euclidean geometry example. So geometry of the plane has a number of rules to it, right? So geometries of the plane has a number of rules to it. For example, the classic one is the sum of the angles of a triangle is 180 degrees. But if we put Euclidean geometry on a sphere, this was the introduction of non-Euclidean geometry. The idea of that is, the axiomatic statement is the sum of angles is greater than 180. So in planar geometry, the rule is the sum of angles is 100. But then in this parallel kind of split of geometry, we call it non-Euclidean, the angles, the straight lines of the triangle become curved lines, and the angles of those lines become greater than 180 degrees. Some other properties that happen as we move from a flat to a spherical model is that in a flat model, parallel lines can stay parallel. A circle circumference is 2 pi r, and a straight path is the shortest path between 2 points. But on a sphere, parallel lines eventually cross. And in a non-Euclidean spherical space, the shortest possible path is an arc, not a straight line, right? So it's an arc. A part of an arc is the shortest line. And then we can even get into hyperbolic spaces, right? Where the sums of triangles are less than 180, where parallel lines diverge, and where a circle's circumference is greater than 2 pi r, just like a circle's circumference is less than 2 pi r, because it actually is going to map out a elliptic or an egg shape, right? It'll be sort of an egg shape. So I don't know the history of the introduction of non-Euclidean geometry, but I'm sure there were detractors of this kind of thinking when it first came out. They're like, what are you doing? You can't do this. But what was interesting is this gave us insights into certain things in mathematics, and I'm wondering why we're not talking about a change of the arithmetic operators as simply a kind of Terry system that you can gain insights. Now, what is the one insight I gained from it? I'm no mathematician, but I just spent a few minutes thinking about it, and I came up with a projection space problem. So just like we talked about earlier, we talked about a sphere. So imagine a sphere, right? Here's a sphere. And then we have a plane below it. And if we project down, here we are, we're back to the shadow of ideas, Giordano Bruno, right? If we project down onto the sphere, we will get that sphere to make a circle in the plane, okay? So the 2D version is a circle. The 3D version is the plane. The other space that I think, so I mentioned that I think the impact, if we were to play out this Terry system, the TH system, the Terrance Howard system, I think some of the implications of the square root of 2 being 1 times 1 would impact things that are kind of explained by complex numbers. It would also impact things about projection space, right? I think projection space will also be impacted by it. If people are in the audience who know something about math and would like to leave some comments that leave some breadcrumbs trail to the witch's house for me, I'd be happy to follow them in a later edition of this, or have the conversation in the chat. The other thing I think would be impacted is the idea of fractals, right? Fractals. Fractals are fractional dimensions, right? So when you see the Mandelbrot set, that has to do with these strange things that happen at the 1-2 point of certain, so fractals, right? The Mandelbrot set, the Mandelbrot set, the fractal images that we see, right? All of those points of the fractal set have to do with this multiplication inversion that happens at near 0. So what am I talking about there? So let's just do a quick number line. So basically, if we think of this as negative numbers and these are positive numbers, multiplication and division will usually result in as you move this way, multiplication numbers get bigger. But as you get to 1, these numbers drop down to negative infinity or infinity kind of, right? So the idea of it is as you multiply whole numbers, they expand. As you multiply fractions, they decrease. And same thing with division. When you divide, it's going to go the opposite way. So division will make numbers, bigger numbers smaller, and division will make fractional numbers bigger, right? So there'll be like a division curve will look like this and going up like that, something like this, off the axis, right? Something like this. So the idea is, if we zoom into that area of here's 1, negative 1, this is where it's going up and this is where it's going down, because you multiply, 0.1 times 0.1 and you get 0.001, right? Something like this, 0.01, right? And I think that there is kind of something implied in this Terry system that's around, and I think that this is an interesting philosophical point. We're talking about the philosophy of mathematics now. We're not talking about mathematics or what mathematicians use. We're talking about an alternate system of mathematics. So the concept here is there a use or is there an exploration that you could do that says why isn't the operator multiplier always increasing? And why isn't the operator division always decreasing, right? And the problem is because of fractions, right? Because fractions, the multiplying of those produces this result, which is consistent with our standard mathematical system. But I think in the Terry system, that I'm going to call this, we're going to see an impact where he seems to be wanting to have the multiplier always increase. And then also there's another area which is about 1, right? The identity formula. He talks a lot in his PDF book that you guys can go read. You can go watch the Joe Rogan podcast. But so there's a lot of insights there that we can take away from it. One thing I wanted to share was, I'll share a little story from me. So I actually back in the 1990s, me, I'm always, if any friends of the podcast know that I'm very interested in world building, alternate science. So I had written this thing. It was in December of 1997. It was called An Alternative to Mathematics. Now, first of all, I want to share the concept of this with you. So I had done this bit of writing here. And I had shared it with a mathematician, and he was so offended by it. But his offense was mostly in anything that you could describe in an alternate system of mathematics could be described in the system of mathematics that we have, which I think is great. But one thing that I think, and I'll share this writing with you in a moment, but one thing I think is interesting when we look at something like the complex numbers, or in something like the non-Euclidean geometry, is by adopting it's called imaginary numbers, but actually it's vector math, right? And actually this, if you go to see our quaternions and octonions podcast that we talked about, in relation to sort of Giordano Bruno in the shadow of ideas, you can see that higher dimensional, we're always reducing higher dimensional to 2 dimensions in our math systems, right? We're mapping it down to a flat system, just like a video game can have the illusion of 3 dimensions, but we flatten it to a 2D screen. And I think that maybe there are some intuitions to be had with something like this. So for example, in this hypotenuse example here, if we think of the shortest distance of a line in flat space is the 1.414 standard math. But if we imagine this in a curved fractional space, I want to say it's almost a fractional dimension. It's not necessarily non-Euclidean. The idea is to, when we encounter this number, perhaps it's an indicator of another kind of geometry in which a fractional projection space is possible. So here we have a hypotenuse that curves, and this is where you get the extra length from. And then I think that Terrance Howard expands this even further, where he comes up with the intersection of the spheres, and he comes up with this tetrahedron-like Terry object, right? He has this object that he's using as the fundamental, and I think it's in the intersection place between spheres. There's a sort of space in here, right, that kind of gets demarcated by this. And he's created this as kind of because I think in the Terrance Howard world, not only would we break the rules of dimensionality to make this 2, it would have to have a curve to it, but then we can also break this 90 degree to make it something like this, right? So it's a hyperbolic non-Euclidean geometry kind of amalgam that the Terrance Howard system is working with, something like this. And I'm offering that as just something that the mathematicians might be able to talk to us about, because even though that they can reduce it to standard math and it makes perfect sense and their system is great, no one's threatening their system, I think that this is where the Terrance Howard possibly is using PR tactics. And maybe it's not. Maybe it's just earnestly he wants to do it. But maybe this gets more attention to make it sound crazy, right? But I'm not sure. And I would love to talk to Terrance Howard. I would love to participate in his work. Let me read a little bit from this Alternate to Mathematics. This really angered my the science mathematician colleague. So an elaboration idea has occurred to me several times. The idea of a radicalization by an amathematical approach is not exactly how it seems to me. It's a science-like study. The idea of an alternate to mathematics embraces the rigors and specifications that the process of mathematics reveals and implies, and it corresponds with it regards to science. However, could you make such a thing possible? How would such a thing be possible? How could what seems to be a perfect foil to the material, the ideal form of mathematics, ever progressing yet still rooted in ancient truths, ever be dethroned? Perhaps I begin with the notion of how the idea came to me. The idea was revealed quickly and all at once. Perhaps in the way Heraclitus claims you can't step into the same river twice, right? The idea is general, no denser than others, born out of nothing. So the possibility of such a thing are now gone, but the idea is, what would an alternative to mathematics be like? All I could think of at the time was the idea of number. Imagine an alternative to number. What would this be like? What comes to mind is viewing the world topologically as a continuous surface. However, topology is quite entrenched in math as well, which would quantify all the areas of roughness and smoothness. Convexity and concavity, with regard to some ground, in the math from the simplest to the most complex surfaces. If we were to have noticed the topology before we counted the objects, what would that look like? So for example, a desk, glasses of beer, continuous topology, a three-dimensional snapshot. You reach out for a glass, and there's a radical and abrupt change in the surface, right? So the classical Greek philosophers, as well as mysticism of various religions, pondered the one. However, to remove this number makes useless most of this sort of thinking. What would lie in the wake of such a departure from the one, from the worldview? I guess being against entering into the quantifiability of each of the alternate images. Is it possible to even imagine an alternative to mathematics? So this is just something that I was sort of playing around with, as sort of a word topic at the time. But one thing that's interesting also from the Terrance Howard discussion is, he also says that zero doesn't exist. And I think this is also another thing that is maybe overblown. Because, if you look at the complex plane again, here zero is the origin. But what if you just move, like instead of doing things at zero, right? What if you just moved everything over to 1? Okay, and you did all your math at 1, and then you take the 0 away. You just relocate the 0. So I think what he's kind of talking about, like for example, in complex, like let's say for example, if you had a parabola, right, that was at origin 0, you could transpose this to say 3, and it still is the same space, and you could transpose it to 3, -3. It's the same parabola. It's just the units, or the center point has been moved. So I guess given that kind of thinking, 0 doesn't really exist in a certain kind of way of thinking. And it's more in a coordinates way of thinking, right? And I think that Howard seems to maybe be suffering a bit from engineering versus pure math concepts. And I think to take it back to pure math concepts, maybe somebody could talk a bit in the comments around this system that I want to call the Terry. And just like with the complex number system, the Terry system would just be the one in which the square root of 2 equals 1. And I think you could explore it from there. And I think from there, the other area that Terrance Howard kind of dives into, which is also something that we've talked about again in the podcast when we were talking in our reviews of artificial psychoanalysis of desiring machines. There's a section in computational complexity in psychiatric agency where you talk about using artificial general intelligence to play out alternate forms of math and science, right? So for example, the example I brought up was, what if we still had the ether as the background material of the void of outer space? And I think Terrance Howard comes into this kind of concept too. So there's sort of an overlap here. For my speculation that we had on the podcast, we talked about if the ether, what if science branched and we could go back and continue following our insights in terms of the ether as opposed to in terms of Einsteinian way. And I think maybe that would have caused some different ways of thinking. I think what Howard's starting to do is he has this concept here. If you take this like a magnetic field, so you can sort of see here's the poles, here's like the north and the south, and then this is the magnetic field going outward from it, this toroidal magnetic field. And at the center of this magnetic field, if you arrange in that sort of Terry object, if you arrange at the center of this a number of vortexes, so these vortexes, imagine these are vortexes going in, and he's got a special arrangement for these vortexes. So you set up a physics kind of simulation for these vortexes. that are going off into the center of this document, something like this, right? So all you've got is the magnetic field, the vortex is spinning, and then you introduce those vortexes here inside of this. You can see them, a number of them here. You introduce a bunch of random particles throughout this, and you start with a low resonance, just like a hum across the system in the physics simulator, but you don't use any gravity. And you introduce these particles. The particles will eventually start to spin and coagulate into a planetary type shape, which he simulates on one of his things as a sort of a Saturn shape, right? So Saturn complete with, now this is what was kind of interesting. He didn't use a gravitational force at all. He just used this vortexes and this thing. But what was interesting is he ends up with the hexagonal shape at the top of the, which is actually, there is a hexagon at the top of Saturn. So this is like a top view down on Saturn. There's a hexagon, like storm, in the shape of a hexagon. So just with the magnetic field and these vortex arranged in his kind of linchpin arrangement of that intersection piece, spinning that naturally, he said that this is the formation. So in a way, I think he expands it to say galaxies form this way. And this is his proof that black holes don't exist and that gravity is not a force, it is an effect. So I think that in his speculation or his observation, his idea was that the gravitational observation is just what happens when the ether is what's making the vortexes, and it's just magnetism and electrical energy. And I don't quite understand all of his points, but I did think it was very interesting to see Saturn emerge in all of this. I think what I thought was interesting also is that, maybe the solar system's asteroid belts were kind of like a ring around the sun, and that galaxies were also being formed by this inverted spiral. He makes a lot of these kind of esoteric observations, which I think makes a lot of people uncomfortable, right? And I think a lot of scientists want to jump right to he's nuts. But I would like to dig deeper into the idea of, this is just another kind of experiment that's pushing against the nature of arithmetic operators, the number 1, the square root of 2, and perhaps coming up with this, if this is the right angle and we've got this hypotenuse that's coming out of the curve, out of the plane, right? The hypotenuse that comes out of the plane that is 2, maybe this is a unit of, I'm going to call it like an engineering or an applied math that you could better describe or more simply describe some kind of fractal geometries. And when I say fractal, I want to focus on fractional dimensional geometries. So when we look at fractals, and I think we have a podcast that we talked about the fractal dimensions too, but when you look at fractals, what I thought was very interesting is when I learned that the different parts of the Mandelbrot set are between 2 and 3 dimensions, right? They're between 2 and 3 dimensions. And I think some of the things that he was talking, just like the complex numbers, are kind of multidimensional. So the complex number, we have 3 plus 2i. It's not a point, like 1 is a point, but 3, 2i is actually a coordinate. It's a vector. And so the idea is just by exploring the complex numbers as a possibility, saying that I is the square root of -1, we get to this plane where we can have a number represent a Cartesian plane. And then when you get to quaternions and octonions, you can do this with higher and higher dimensional objects. I'm wondering that if we explored just this small concept, which we're calling the Terry, what would be the effects that ripple through the maths, that we could help to understand where these compressions were. And another one, I bet you there's something interesting here with quantum wave collapse, right? So the last one, I'll leave you guys with this one. So I think that the problem is in what I noticed about it's illustrated in my example, right? The illustration in the example is here we have the flat line, and here we have the wave line, right? So when we go toward this math, the line, this number represents the collapsed version of the line. This number is sort of like the imaginary length. The Terry length, let's call it the Terry length equals 2 for this hypotenuse. The Terry 2 means it's not, the wave has not collapsed yet. Maybe it's unobserved, right? So the idea is, and I think I'm holding to the right angle still because I haven't quite got my head around if we collapse the right angles too. But like I think what's scary about this is, and again, when Terrance Howard talks about the periodic table, I saw chemists saying, "Oh no working chemist today would think this way," and I don't think that that's the right response. I think this is something that's looking at the periodicity, looking at the double binding elements, like hydrogen, like nitrogen, like oxygen, like fluorine, like going through those at Terrance Howard, and then he does that spiral. He does a spiral where he talks about their octaves of each other. I think it is not only is it poetic, I think it speaks to a kind of symmetry, and it speaks to a kind of way to get more insights out of the current science. Listen, I understand that a lot of scientists will just say, just learn the normal science. But what if it was a simpler way, like an easier way to look at it, or a way that you wouldn't need so much convoluted maths to get you to a similar answer? Or what if, if you're looking at something, I even think about, I've often been interested about what's the topology of the Mandelbrot projections that we see in those visualizations. And I'm wondering if something like this, observability, wave collapse, and the suspension of wave collapse, the unobserved wave collapse implied by this, I wonder if there's something that could be explored here. Just like the complex numbers explored things, and just like non-Euclidean geometry explored ideas. So this is what I'll kind of leave it at that. The Terrance Howard, if you watch this, anyone else who's watched the Terrance Howard thing, want to comment, please do. I think of it more like an experiment than something that's breaking scientists or making him seem crazy or threatening academic things. It's just they've been doing this forever. We've taken flat geometry, put it on a sphere, and came up with new ideas. We ended up compressing 2 dimensions into 1 dimension with complex numbers, and compressing 8 dimensions and octonions down to 2 dimensions, right? So we've been doing these kind of experiments all along. There is some implications of taking the registers, of taking the arithmetical operators, and making them consistently growing and dividing, that I think he's addressing. And that's kind of more of a theory of math. Right, in the end, all of the Terrance Howard things, I think they're explainable by standard math. But there's insights, perhaps, into, well, why are we dividing down to 0, as opposed to looking at the arithmetic operators in slightly different way as an experiment. So that's where I'm going to leave it. I'll leave it at that. Guys, leave your comments. Got a Patreon down below. Thank you guys for watching. Go check out our bookstore as well. We've got the Artificial Psychoanalysis of Designing Machines out there. And hopefully this was somewhat interesting to you guys. Talk to you soon. Bye-bye.